Hey everybody, so in this video I will be explaining about thermophysics. So in this video I will be teaching about the 5 units of temperature. The first one is Celsius. It is named after Anders Celsius. It has for water, it has a freezing point of 0 degrees Celsius and a boiling point of 100 degrees Celsius. The second one is Fahrenheit. No, it is named after Gabriel Daniel Fahrenheit. It has a freezing point of 32 degree Fahrenheit and a boiling point of 212 degree Fahrenheit. The third one is Kelvin. It is named after William Thomson, first Baron Kelvin. It has a freezing point of 273 Kelvin and boiling point of 373 Kelvin. The fourth one is Reaumur, named after René Antoine Herschel de Reaumur. It has a freezing point of 0 with the boiling point of 80 degree Reaumur. And the last one is Rankine. It is named after William John Macquorn Rankine. It has a freezing point of 492 Rankine and a boiling point of 672 Rankine. So as you can see here, the symbol for Reaumur and Rankine is similar, but for Reaumur it has degrees, so you must remember this. Do not get both of these mixed or confused by it. So converting units of temperature. To convert a temperature from a unit to another, there is a certain formula called a conversion formula. So it is the temperature minus the freezing point of that unit over the range, which is basically the boiling point of a unit minus the freezing point. So for example here, we have convert 64 degree Reaumur into degree Fahrenheit. So first, we will follow this conversion formula. So temperature 64 minus the freezing point. So the freezing point of Reaumur is 0 over the range, which is the boiling point minus the freezing point. So 80 minus 0 will be 80. So this is for the Reaumur. Now we made the formula for Fahrenheit. So temperature in Fahrenheit minus the freezing point, which is 32, over the range. So the boiling point of Fahrenheit is 212 and the freezing point is 32, so its range is 180. So now we just count it all. So here we can cancel, divided by 20, 4 and 9. So we cross multiply. So the temperature will be 176 degree Fahrenheit. So yeah, that's it. Pretty simple. It should be clear. Let's move on. Calorimetry. So calorimetry is the process of measuring amount of heat released and absorbed by a physical or chemical system. So the formula is Q, or calor, is mass times C times delta T. So units of heat. There are several units of heat, and the ones that we are going to learn today are calorie, or cal, which is the amount of heat needed to raise the temperature of 1 gram of water by 1 Celsius. Kilocalorie, or kcal, it is the amount of heat needed to raise the temperature of 1 kilogram of water by 1 Celsius. Joule, or J, it is the amount of heat needed to raise the temperature of 1 kg of water by 1 Kelvin. And the final one is British thermal unit, or BTU. It is the amount of heat needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. So you have to remember this, how much is being raised and what's the temperature being raised. So here there are some conversions. 1 kilocalorie is the same as 1000 calories. 1 calories is the same as 4.184 joule, and 1 British thermal unit is the same as 1055 joule. Specific heat capacity, or C. So as earlier we had the equation or the formula Q is equal to mc delta T. Let me just write it down. So the C here is the specific heat capacity of a substance. Now here, this is the heat capacity of some substances that you can use later on when solving for problems. So let's solve the first problem here. A 7 kilogram block of ice with a temperature of negative 24 degrees Celsius melted to a temperature of negative 7 degrees Celsius. How much kilocalorie of heat was absorbed by the ice? So we identify what's given. Find how much heat was absorbed. We use the MCT formula, MC delta T, sorry. This will give us, we see here, 249,067 joule. But first, we need to convert it to kilocalorie. So joule, if we remember earlier, the conversion from calorie to joule. So 1 calorie is equal to 4.184 joule, and 1 kilocalorie is same as 1000 calories. Sorry for the writing. So here we can cancel joule with joule and calorie with calorie, so we will be left with kilocalorie. And if we input this all in a calculator, we will get 59.53 kilojoules, and this is rounded up. So let's move on to the second problem. 10.8 kilojoule of heat was absorbed by a block of aluminum with a change of temperature of 68 degrees Fahrenheit. So what is the mass of the aluminum in pounds? So first we are given the amount of heat, or Q, 10.8 kilojoules. So first, remember the conversion of units. So the delta T is 20 degrees Celsius, so we got it. Now it's time to find the mass. So find the formula from earlier. Q is equal to mc delta T. So 10,800 is m multiplied by 920. So we divide 920 from this side to this side. So the mass will be 0.6 kilograms. And this is not the final answer. We need to remember that it is asked in pounds, so we convert it. So 1 kilogram of 1 kilogram is equivalent with 2.2 pounds. So we put 1 kilogram here and 2.2 pounds here. That way, kilograms and kilograms can cancel out each other. So we will be getting 1.32 pounds of aluminum. Sorry. Go. So that's pretty much it for calorimetry. It's pretty simple. So I hope this was clear. Let's move on. So effects of heat. Heat can affect a substance in two ways. So there could be change in length, or we call linear expansion, and change in volume or volume expansion. So for linear expansion, this is the formula. Delta L is equal to alpha initial L times delta T. Alpha meaning coefficient of linear expansion, and here for volume expansion, the delta V is equal to beta times initial volume times delta T, with beta being the same, the coefficient of volume expansion. Oh, by the way, if the problem is given only alpha, but we are being asked for volume expansion, you can turn alpha into beta. So beta is equivalent to 3 alpha. And if we are being asked for the area expansion, you can use 2 alpha. Okay, so that's clear. So let's try to solve question. So here, 80 milliliter of CH3OH. So this is volume expansion, given volume. Initial volume being 80 milliliter. So if you remember, the formula for volume expansion is delta V is equal to beta times initial volume times delta T. So here, since it is in degree, we have to convert this into degree Reaumur to Celsius. So this is same as 44 degrees Celsius. So here delta V, this means that it is the difference between the final volume minus initial volume. So we're trying to find the equation for delta T here. So we transfer initial volume. So it will be 1 plus beta delta T. We divide both sides by initial volume, so V per VO. And then transfer 1 to the other side. It's equal to beta times delta T. We divide everything by beta, so the formula for delta T will be V over VO minus 1 over beta. And since delta T is the difference between the final temperature and the initial temperature, so the final temperature will be V. Let me write in a bigger space. So final temperature is plus initial temperature. So we just write everything into this equation here. So the final temperature will be 49.25 degrees Celsius, or we can simply round it off to 49.3. But wait, we're being asked the temperature in Reaumur, so we have to convert it once more. Let me just erase some of this. Okay, so to convert Simply follow the conversion formula. The final temperature will be 39.4 Reaumur. So let's move on. Thermal equilibrium. So when we say equilibrium, so it means that equal or balance. So thermal equilibrium happens when two media with different temperatures reach the same temperature after direct contact when one loses heat and one gains heat. So in this illustration, you can see that the media or substance with lower temperature and higher temperature collide with each other or has direct contact. So here, heat gain is equal to the negative heat loss Q. The Q gain is equal to negative Q loss. So for example here, 200 grams of aluminum at 80 degrees Celsius is submerged into 500 grams of water at 25 degrees Celsius. What will be its final temperature after reaching equilibrium? So we follow the formula, the equation. So first we identify which one has lost heat and which one has gained heat. So usually the higher temperature, the one that has high temperature will lose heat. So aluminum will lose heat here. Just and the one that gain heat will be water. So we follow this again. Q gain is equal to negative Q loss. So 0.2 Q is MC delta T. So 0.2 times 900 times 80 minus the final temperature will be equal to 0.5 times 184 times T minus 25. So let me write it up here. So we transfer 52,300 and 180 T, and when we divide, so we will get a final temperature of 29.4 degree Celsius. Alright, so that's it for thermal equilibrium. So let's move on. Latent heat. So latent heat is the energy released or absorbed by a substance during a change in state. So there are two types of latent heat. The first one being latent heat of fusion, and the second one is latent heat of vaporization. So here, as you can see here, substance at this point will be solid. So this will be, let's just say that this is the first heat Q1, and then there will be fusion here, or melting or freezing. So at this point here, this will be LF, and here from this point to this point, this will be Q2. At this point right here, there will be an vaporization or condensation, so LV, and from gas onwards, this will be Q3. So this is the simple way to remember it. So let's try, for that, let's see the latent heat of substances. So here I have made a table containing the latent heat of fusion and vaporization of some substances, so you can use this to solve for problems. So the temperature here, meaning that at this temperature here, for example, water at 0 degrees Celsius will fuse or will melt, and at temperature of 100 degrees Celsius, water will evaporate. So let's get to do some problems. 3 kilograms of ice at negative 20 degrees Celsius is exposed to heat until reaching 67 degrees Celsius. How many kilojoules would be required to reach that temperature? So first we draw the graph. So first let's find Q1. So for Q1, we simply follow the formula Q is equal to mc delta T. So this will yield 125,580 joule, or if we want to convert it into kilojoule, this will be 125.58 kilojoules. For the latent heat of fusion, we use the formula mass times LF. So the LF of water, as you can see earlier, let's check. So it will be 354. So, and for the last part, we have to find Q2. So here, why is it 4,184? Why not use the heat capacity of ice, which is 2,093? So here, for this will be the heat capacity of water, and since ice has melted into water, we will use the heat capacity of water. So at Q1, it is still on the form of ice, so we use the heat capacity of ice. But on Q2, it is water, so use the heat capacity of water. So we multiply all of this together. So to find the total, we just add it together. So it will result in 1,968.564 kilojoules. Moving on to the final part of this video, heat transfers. So you probably learned this earlier, either in SMP or SD, but I'll just remind you again. So the first form of heat transfer will be conduction. So this is the process in which heat energy is transmitted through collisions between neighboring atoms or molecules, and this occurs in solids and liquids since they have a much more compact structure. So the molecules is packed tight, unlike gas, which is spread around. So the second one will be convection. Convection is the transfer of heat related to the movement of fluid due to the rising of higher temperature materials and sinking of lower temperature materials, and this occurs since hotter temperature has that higher density than lower ones. So for example, if you are boiling water, if you observe it, water will, the bubbling water will, let me just throw it. So for example, this is hot water. So the hot water above, the cold water, since heat is being absorbed by the pan here, so the bottom one will get heated first, and then it will move up and go down. The top one here will go down, and so that's basically what convection is, the movement of fluid. And the last one will be radiation. So radiation is the transfer of heat by electromagnetic waves that doesn't require any medium to be present. So for example, this could be the heat of sun entering the earth. So yeah, I think that's basically it. So that's it for the video. I hope you could understand the topic better. And yeah, that's pretty much it. Thanks for watching.